So far we discussed some of the criterion related to proving the two triangles congruent, right? There were 5 of them. So now let's discuss some important theorem. This is the very important theorem that we are going to use in this chapter, and the quadrilaterals and circles and areas related to parallelograms and triangles as well. This theorem is very important. So let's start with the new theorem. So theorem says that the angles opposite to equal side of a triangle are equal. Okay, so first of all we need to understand the basic idea of what does it mean by the equal opposite side and equal angles, right? So let me just give you the rough idea that what does it mean. Let's say we have this triangle XYZ, X, Y and Z. Now the first condition, the angles opposite to equal side, right? Now first of all let's take the equal sides. Let's say XY is equal to XZ. These two sides are equal, and what we are supposed to take, angle opposite to equal side. Now first of all we need to talk about the opposite angle. Opposite to what? Equal sides. So XY is the one side. What is the opposite angle to it? See, you need to just draw the arrow. That is angle Z. Opposite to XY is angle Z. And here XZ, what is the opposite angle of XZ? That is, let's draw the arrow, that is angle Y. This is what this theorem means, right? Understand the basic idea, because see, this is the very simple case of the triangle. We are having only one triangle. We are going to discuss the questions where we have more than one triangle, right? There you need to judge, you need to draw this arrow to understand that which is the opposite angle, right? So let's repeat one more time. You need to have the equal sides. Yes, we have it. Two sides are equal. Basically it is isosceles triangle, remember. Okay, so now opposite to XY is what? Angle Z, and opposite to side XZ is angle Y. So these two sides are equal. So opposite angle to that side is equal in a triangle. We cannot take randomly, right? We cannot take any other shape. Remember, it is related to triangle. So this is what we are supposed to prove. So let's start with the proof. First of all, let's name it here A, then B and C, right? So let's write given we have triangle ABC. Now what is the condition? I told you we should be having two sides equal. So let's say AB and AC equal. So in triangle ABC we can write AB is equal to AC. Basically it is isosceles triangle, right? Because it has two sides equal. So that's done. Now what we need to prove? So let's write proof. First of all, see, opposite to AB, what is the angle? That is angle C. So we want to prove angle C is equal to opposite angle to side AC, that is angle B. So angle B it is. This is what we want to prove, right? I explain you how we are writing this thing. The same method I have used over to write this. Let's start with the proof. So proof. First of all, I'm going to take one angle bisector. Okay, angle bisector of A, that is AD. Let's say AD is angle bisector of angle A. Angle bisector, right? Bisector means what? Divide into two equal parts. Now it is angle bisector, so it is dividing angle A into two equal parts. So this angle and this angle will be equal. This is what it means, right? Angle bisector. So let's write over here which two angles will be equal. Let's write first of all that. So angle BAD, right? Angle BAD. So BAD is equal to angle CAD, angle CAD, right? These two angles are equal. That being done. Now, how to prove angle C is equal to angle B? That's the confusion. Okay, so let me explain you the strategy that I am going to use. Very simple. We want to prove these two triangles congruent, right? By CPCT, we can write angle B is equal to angle C. So treat this as the normal sum that you want to prove these two triangles equal, right? And conditions you have is this AB is equal to AC. Another condition that we have taken angle bisector, this, right? So we have one side, we have one angle over here. So what do we need? Something else? You can recall there are 5 conditions. Let me note down: S, 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 A, S, A, S, A, then A, S, and finally R, H, S, right? These are the 5 conditions. Now we have one angle and one side. So there are basically 3 options we can choose from: SAS, ASA, AAS, right? So how shall we approach this? See, we have the side, we have the angle. Now either you need side or either you need angle. So let me just draw one more time here, that let's say this is A, D and B, right? And here let's say this is angle A, D and C. See, AB and AC is equal, we know very well. Now this angle, as this is angle bisector, this is also equal, right? So 2 conditions are given, side and angle. Now observe one more thing, that AD is the common side. AD is the common side. So we got the condition, right? This is side, this is angle, and this is side as well. So which is the condition? SAS, side, angle, side. Here as well, this is side, angle, and AD is the common side. So let's prove that. So we can write here side, angle, side. We have one side, AB is equal to AC. Then angle BAD is equal to angle CAD. This is your side, this is your angle, and the last side, which is AD. Let's write here AD is equal to AD, that is common side. Common side. Then so we can write by SAS criteria, by SAS we can write triangle BAD is equal to triangle CA, congruent triangle CAD, not equal but congruent, right? That being done, now what we wanted to prove, we want to prove angle C is equal to angle B. So by CPCT we can write C, B goes with C, right? This is what we wanted to prove. So we can finally write angle B is equal to angle C. We have proved it, right? This is very simple thing to do. Just you have the isosceles triangle at the start of the question, and one extra thing you need to keep in mind, take the angle bisector, and at the end what you need to do basically to prove these two triangles equal, right? You can use any of the 5 conditions that we have discussed so far, done, and afterwards by CPCT we can write that angle C is equal to angle B. So treat this as the normal sum, right? And 2 steps you need to remember, that isosceles triangle and the angle bisector, and you prove that. That's it, 2 triangles equal. So this is the theorem, very simple it is, right? And remember, opposite sides, first of all you need to take 2 equal sides and opposite angle to it, that is equal. So this is the theorem, and this is how we prove the theorem. So we discussed the theorem. Now let's solve problems based on the theorem. So let's start with the first question. We have the figure in the question only, that's good, right? Let's start. In the given figure, triangle ABC is an isosceles triangle in which AB is equal to AC. So this triangle is isosceles. So side AB is equal to side AC, in which, right, AB is equal to AC, and LM is parallel to BC. Okay, interesting point here that LM is parallel. First of all, let's write that conditions AB is equal to AC, right? And another it is given that LM parallel BC. So let's write LM parallel BC. Simple. And angle A is equal to 70 degree. Find angle LMC. LMC. This question mark we need to find. We have the value of angle A. Simple. So how shall we approach this one? Right, this is very easy at some point, but you need to have good insight into that. So these are the given conditions, right? And we know one more condition. Let me mention that this is triangle ABC. I know why I'm mentioning, we know that it is triangle, right? But it is condition that we are going to use it. Okay, we'll come to that part later. First of all, let's start with the first condition. AB is equal to AC. Means what? We learned the theorem right now, right? Angles opposite to equal sides are equal. So let's write that one, that angles opposite to equal sides are equal, right? We know very well. Now let's write AB is equal to AC. Now in this case, okay, in this case, what is the angle opposite to side AB? Remember we talk about side AB whole. So opposite to that is what? Angle C, right? So we write angle C is equal to, and opposite to angle AC, that is what? Angle B. So angle B it is. Okay, that being done, so it means that value of angle B and value of angle C is same, right? So let's take it as X. Let's take as X. Done. So now we know one thing very well. Let's write here that angle A is equal to 70 degree, angle B is equal to X, and angle C is equal to X. Now I told you that triangle ABC is also one condition. Means what? Angle sum property. We are going to apply the angle sum property. Triangle ABC angle sum property, right? It means that if I add all the three angles, angle A plus angle B plus angle C is equal to what? 180 degree. Now let's substitute the values. Angle A is 70 degree. Here it is X. Here also it is X is equal to 180. So 70 will be shifting there. X and X is what? 2X. Here 180 degree minus 70. Do not forget to change the sign. You will be getting incorrect answer otherwise. So 2X is equal to 110. So X is equal to what? 110 by 2, that is 5. 2 ones are and 5s are and 5s are. So X is equal to 55. Okay, this angle is 55 and so do this angle, because this is isosceles triangle. I hope you are able to understand so far. It's simple to do, right? We get the value of B and C. Now first condition we use that two sides are equal. Now let's come to the second condition, parallel lines and angles chapter. So let's start with another condition, that is LM parallel BC. Now what does it mean? Let me just indicate that these two lines are parallel. This is a sign. Okay, now observe, let me show that this is transversal, right? If we consider that this is the transversal, if we consider MC as the transversal, let's extend that as well. Okay, we can see that these two angles are IASS, interior angles on same side. Let's mention interior angles on same side. Done. Now what does it mean? If I add these two angles, I'm going to get what? 180 degree. So let's mention first angle is angle LMC plus here, right? This is what we wanted to find. See in the question, this angle and these two angles will make 180 degree. This is LMC, and this angle is, let's say, angle C here is equal to 180 degree. Simple. Now LMC that we want to find, so as it is, plus angle C value is X, that is 55 is equal to 180. Now let's shift this 55 over there. So angle LMC is equal to 180 degree minus 55 over here. Remember 55, right? 10 minus here 10 and here 7. 10 minus 5 is 5. 7 minus 5 is 2 and 1 here. So what is the value of angle LMC? That is 125 degree. We just find it, right? So here, remember, we use so many conditions at a time. We use the isosceles triangle, right? AB is equal to AC. That is the theorem in our case, and another parallel line condition, and one more angle sum property. So there are three conditions we used in the one sum to get the answer, right? So this is how we solve it. Let's start. Let's repeat one time. So we have condition AB is equal to AC, angle opposite to equal sides are equal, right? We get the two angles equal. Then we have the value of all these three angles. Angle sum property, get the value of the missing angle. Then interior angles on same side because two lines are parallel. So this is how we find the missing angle with the help of the theorem that we discussed. Let's discuss one more question. This is about the right triangle. Let's start with the question. In triangle ABC, right angle triangle, in which angle A is equal to 90 degree and AB is equal to AC. Find angle B and angle C. So we have the value of angle A and two sides are equal, and we need to find the two missing angles. Now see over here, this is very simple question, right? You have the right triangle and you have the isosceles triangle as well. So this is isosceles right triangle, right? One condition for this side, isosceles, two sides are equal, and right triangle, one another condition for the angle. So this is isosceles right triangle. Let's mention whatever information is given. Angle A is 90 degree. So this will be angle A and this is 90 degree. Simple. Second condition, AB is equal to AC. So let's say A, B and C. These two sides are equal. Done. And what we need to find? We need to find these two angles, right? Angle B and angle C. Let's mention in triangle ABC, angle A is equal to 90 degree and we have AB is equal to AC. Now what we are supposed to do? We are supposed to use the conditions. There are two conditions, triangle ABC, that is also a condition. If you can recall the previous question, then AB is equal to AC. So let's start with this one. AB is equal to AC. Apply the theorem. Angle opposite to equal sides are equal. So let's write angle opposite to equal sides are equal, right? So we have here AB is equal to AC. So what is the opposite angle of AB? Angle opposite to AB, that is, right, AB, this is this side. So see, this will be the angle C, angle C here, and AC, that will be angle B. Or you can even remember like that. See triangle ABC. If side AB is there, then what is the opposite angle? C. And if side AC is there, then what is the opposite angle? B. Very simple, because there are only three angles in the triangle. If you just take out two, whatever left will be the opposite. Simple, right? So that can help you as well. Now let's take this as well, X again in this case. So now it will become very simple to solve it, right? We are going to use what? Angle sum property. So angle sum property. So let's write angle A plus angle B plus angle C is equal to 180 degree. Now angle A value, it is already given into the question, that is 90 degree, plus angle B and C both are equal, and that is X. X and X here as well. So this x and x will add up as 2x, and this 90 degree we are going to shift, so it is going to become negative 180 degree minus 90 degree. So here 90 degree and here it is 2x. So value of x will be what? 90 degree over 2, that is 1 0 and 45 0. So x is equal to 45. Now remember one thing, this is angle B and as well as angle C. Very simple sum to solve it, right? It was way shorter than the previous sum that we discussed, right? So there are two conditions. Actually, most information is given into the question only. Figure was not given, right? Because it is simple to draw as well. Right triangle, everybody knows that. One angle is 90, rest two are missing, and these two sides are equal. So we use the first condition, angle opposite to equal sides are equal. So two angles will be equal. Then angle sum property. So add all the three angles and find the missing angle. So this is how we find the missing angle B and C in the isosceles right triangle.